Hello folks, well it's Monday and it's the 16th of December and we're going to look at this DNT Scanner 40 which has been sent in as a donation. So it's got no transmitted audio. It's pretty immaculate. These are CPT 40 channel FM, so they don't do UK channels. So it's pretty useless, but I have covered these before, and there we go. But we'll do this one, and then it can be sold on to help the costs of running GB3GR. In a bag has come the remains of the microphone, which wanted wiring for it. So the person who's donated it's had a go. Good for them, and they've not managed to get there. Well, they've done better than me at not losing the screws. So here's the query. I take it that's original, because it doesn't look like it's an aftermarket one. So the easy thing to do without having to look at the circuit diagrams, which I do have, is if I could find our sample DNT Scanner 40. Pause the video, see what I can look for. Well, I can't see our Scanner 40, but I can see the Rally 40, another CPT set, which looks like it's the same mic, doesn't it? So, if this has a mic in it, I bought this from somebody in Wales on eBay some years ago, and they weren't prepared to mail it, so I drove 240 miles to Wales, really for a day out, to fetch it. So there we have, it looks like a Kerno 1100, B2 1100, doesn't it? Which is fine. So it's PR27, and that, see what the pinout is. Different plug, isn't it? That's going to be a great help, but you never know whether the same colour wires are used, do you? So between that and the circuit diagram, see what model mic this is. It's an M1, whereas this is an M4. Certainly got different screws for starters. So, it's a totally different board inside, so it's no help whatever. Oh well, you can see my way of thinking there, can't you? It's we'll have a look. Right, well, put that back in the box. So we've got the internal connections here. Hopefully the circuit diagram yeah, well I can see the donor's problem because it's not stated, is it, on here. But what it does do is it does tell us what the pinout is. Pin 1 is mic input, pin 2 is something audio, pin 3 is PTT, pin 4 is ground, pin 5 SO sale. What does that mean? Pin 6 up and down, pin 7 9 volts or 8 volts, and pin 8 13.2 volts. If you get some of these wrong, there's a lot of blowing up going to happen, isn't there? So in the gentleman's letter, it's got it going into transmitters and up and down, but no audio. So if we look at the and this is I haven't even got a jig made up which does 2, 4, 6, 8 pinned in. I'll tell you what we're going to do, because we know the circuit diagram tells us some of it. We'll get it powered up and make sure we're current limit. I'm going to run it at I'll run it at 12 volts, I think, and with 300 milliamp current limit, just like that. So there we are, it's lit up. And get rid of that and put it on channel 20, so we're in the middle of the band. I may as well connect it to the test set just in case we're going to transmit. It is pretty immaculate though for not quite 40 years old. We'll put the signal generator on. I'll just put picture in picture on, and we'll go to camera 2 and we'll put 27205 with it being COPD. Isn't that some illness? With it being CPT. So there we are, channel 20 CPT, and hopefully the set works. Yeah? Well, in fact, noise blanker isn't lighting up. Yeah, scan is. Those are. We've got no receive. I'm on the right channel, and although we wouldn't be able to hear it because there's no mic connected, we should be showing. I've got a whacking great big signal on. I've got, you know, like 100 microvolts plus on. So it's always possible that something is blown up. Right, so we'll plug in the mic. he says, let's go to main meter. He says that it goes into transmit the way he's got it wired. It does look, there we are. It's nearly doing 2 watts as well. So let's look at where the audio goes. If I can remember how to put this on CPT, I think you press the FM, AM, FM button, and when it says AM, it actually means CPT FM. There we go. So hopefully we can hear the audio, and it's going to be that yellow one because we can see that's the screened lead. So if I hold that and put my finger on that, we can just hear a disturbance. So that's the transmitted audio. So if we look at the way this is wired, that's going to be ground, and that looks like sleeving over the shield, which is what you'd expect. So that's going to be the ground side. This is going to be audio hot. So is it shown on, did we say it was shown on the circuit? No, it's not shown on the circuit, that's why we're struggling. So unlike a usual CB, it doesn't go through the PTT switch. I'm going to have to take this subboard out. Try and keep the mic connected because it's going to be polarity conscious. So we want to know what's going here and what's there. Well, the fact there's a capacitor there is going to tell me we've got audio going through it. So that's going to be the audio coming out. So you can see my logic. It's going to pass through a capacitor, and that will not let it pass a DC voltage. So if we solder that wire, I'll just tin that. So we've got a white wire and we've got a violet wire. Now we're not going to get audio until we get power to this. So let's meter, I'll put the radio back on and let's meter what we've actually got on those two wires. I would expect it to be the 8-volt rail, not the 12-volt rail that is required by the mic. So the purple wire has 12 volts on it. The white wire has diddly squat on it. Back to the square kit diagram. Or is that 0 and not 8? See, although this is a first generation scan, I didn't do it, and it may not be the resolution that is ideal. So 7 is what we're looking at. Yeah, I think it's 0. Well, I'm going to start by putting the violet wire to there, so it's going to be powering the element, which is clearly what happens there. One, two, 1, 2. So this white wire, which appears to be 0, you'd expect to go we've got no receive on this, have we? I can see the dilemma. Point is, we've got no receive on this radio, have we? So does this have to have receive going through the mic? Because I don't think it does. So the speaker goes straight to there. You can see the points to there, to the extension speaker socket. We know it's connected because it's making an FM squelch noise momentarily. So we know the audio amplifier is running. And the audio amplifier is coming in as far as I can see, it doesn't go through the microphone like a traditional set. So unless the internal squelch is well, there's two things we'd expect. One, that when you turn the squelch down, the radio would hiss, which it doesn't. And secondly, it isn't showing any signal coming through, and yet we know the thing is working on transmit. We've seen that on the signal generator on the test set. So we've got no FM coming through. Let's just key it up again so you just hear that FM hiss. Actually, of course, that might be my... Just turn that off. There is noise coming from the internal speaker. I think it's time to open it up. Pause the video. So what I'm looking for, having opened it up, you've got this scan generator board, which is using the Sanyo LC71817191, which is the scan generator chips. They communicate by serial data, and on the binary tone breaker phone, you've got, it may be, no, it's not the same. I don't think it might be the same on the audio line 342, but you've got the extended remote, haven't you? Because you can have an extension cable and have the rig in your boot, and the handset on the dash. So that's the advantage of having serial data between those two chips, so that you've only got a screened wire between, and not traditional a dozen wires between the channel selector switch and so on. So that's how it does it. It's a Sanyo chipset, and that's of course all working. Interesting, it uses Philips type transistors, not the Far Eastern ones, even though this is no doubt made in Hong Kong or something. Doesn't say, does it? Anyway, so what the plan of opening it up was, it's the nicest constructed DNT I've ever seen. We've got a standard SRBP board here, but I've got a feeling it could be fiberglass. I can't see the edge properly, so. But yeah, it looks like it's fiberglass, which is incredible quality for DNT. So what I'm looking for is the squelch preset, in the hope that we can turn the squelch to 0 and the thing will hiss. You know what? RV3 looks a possibility. See if whether I'm barking up the wrong tree. So if we can find the squelch control, receive meter, transmit meter. Come on, where's the squelch? Ah, here. Squelch is there. So it's just one end's grounded. Yeah, it's it is RV3, the squelch preset. So my guess was right. So I'm going to have to plug the extension speaker in. I'll use the wall mounted speaker rather than the test instrument one. Power back up. So I can't see any reason to need to put the mic in. We'll turn that preset in the hope we get FM hiss. But we don't. My guess is there's no 8-volt rail for receive. So I'll look into that. Okay, so when we look at the circuit diagram, we're supposed to have on pin 4 the receive rail. So if we look down here, we've got a 13.2 volt regulator somewhere here. That goes down to this scan generator board. So the fact that that's lit up, we know there's 13.2 volts. Then it goes through transmit switch, which we know works because it goes into transmit. And then between transistor 14 and transistor 15, it goes to, that generates the receive rail. So if we follow E up to where it says E, that takes us to the receive rail. So if we monitor pin 4 of the FM chip, which in this case is an MC3359, not the 3357, the 3359, it's pin 4. So therefore we should have the receive rail, which I'm expecting to be 8 volts, to be at pin 4 of the IC. Now, chassis is negative, and we can prove that by going on the power input. We'll see on the meter we've got 12. I'll tell you what, we're going to go to 13.8 volts because it's a 13.2 volt regulator which we're wanting to prove. So we've now got 13.8. So when we go to pin 4, 1, 2, 3, 4, we have absolutely nothing. So it looks like we've got this transistor dead. So it's either going to be transistor 14 or transistor 15. So if we look at, so we know that it's generating a transmit rail and not giving us a receive rail. So if we look for transistor 15, if we can find it on the layout easier than poking a head in the radio. See, because you're never going to get a mic to do any transmitted audio when the voltage rail's missing. Q15 is what we're looking for. Let's have it this way on. See, it doesn't. Oh, it does say squelch adjust. I was going to say it still doesn't say that, but it does. So Q. I've already forgotten. I've got a memory like a sieve, folks. Absolutely. I've always been the same. Q15, possibly 14. Well, I can't see many transistors are shown on here. I'm going to poke my head in the radio, aren't I? As soon as I took it off record, it was there, wasn't it? Switch, make sure the radio's on. So we've got 14 there, and we've got 15 there. So back to the square kit diagram. We're supposed to have on the collector, we are supposed to have the rail voltage, whatever that is. Of course, it doesn't tell us which one's which. Let's see if we've got 8 volts there. Nothing there, got nothing there. Let's just look at 14. We've got 8 volts there, nothing there. No, I'll tell you what, we'll take both those out and test them. Okay, so they're both a PNP transistor, and they're both the same, 2SA 1657 I think it is. I'll get the magnifying glass. That's broken, showing as a diode. So that first one was 15. Here we go again. And that one's working. That's transistor 14. So as you'd expect, the one that has its output is the knackered one. And the number 14 is being protected by 15. Can you see them on the diagram now? I've got them out. Yes, Q14 and Q15 now got them out. Right, let's see whether I can verify what that number says. To us A1267, to us A1267. Well, we're probably looking at the big book of equivalents for that. So make a note in bigger writing. 2SA 1267. Just in case you don't know, when a transistor says A 1267, it means 2SA. But be aware of this other thing. If you get a, you can have a situation with European transistors like BC237, BC238, and so on. But it may only say C237. It doesn't mean 2SC237. You've got to know whether the thing's Far Eastern, whether it's European. Just a point. And seeing as these are designed in Europe but made in Hong Kong or somewhere, you can end up with a situation like we've got with those Philips transistors, which are BF series, but then we've got Far Eastern transistors in the majority of it, so it can be a bit of a quagmire. Well, I'll see if we've got anything. Okay, so what we're going to do is abandon this at the moment. I've got the transistor now on order, but this chance, the chances of getting that this side of Christmas are pretty nil. It's coming in from the Far East. There's probably equivalent. I don't need to do it. There's no grass growing around it. We've got some pictures of something similar. There's a slightly different control board off the internet, and I did just find those, which can also help. I was looking to see if there was a photo of inside this microphone, and at the same time got the data sheet for the 2SA1267 transistor. So Jiangsu Shangjiang Electronics 2SA1267, and it's what you'd expect. That said, it will do 0.4 of a watt, which is 400 milliwatts for that kind of size is pretty impressive. Reminds me of the days of the Z-line for anti-transistors. So we've got the parameter. I don't need to be starting to put equivalents in. We just wait till it turns up. So what we'll do, we'll put everything back in this bag. If anyone's got one of these microphones, the M1 DNT microphone, and they fancy taking the back off and taking a photo of the inside and emailing it to me, that would be greatly appreciated. So this is how between the customer and myself I've got it guesstimated at the moment, and I think we're about right, but don't know where that white wire goes, if anywhere. Could go there, might go common to there, who knows. I think we're probably about right with that. So we'll put all this back in this bag. Including the duff transistor, and we'll draw this video to a close. So I hope you found that kind of path of thought interesting. We've got to the bottom of the problem, and I'm absolutely convinced as soon as that transistor's in, we'll be back having receive. Because chances are that the transmitted audio isn't going to, there's a possibility transmitted audio isn't going to happen without that voltage regulator working. Perhaps it might. Perhaps we're barking up the wrong tree. But until we've got receive on it and we can prove it, I think it's time to move on to a different set. So thanks for watching the first part of the DNT Scanner, which is a PR27B set from about 1987.